Welcome. In this section, we are going to discuss about drift current. So, let us first talk about mobility. So, mobility of a charge carrier is defined by drift velocity upon electric field. And current current will be given by I equal to NEA into drift velocity. And similarly, when you transfer this A to the left hand side of equation, so this will become I upon A and equal I upon A equals NEA VD. So I upon A is a current density. So J is equal to NEA into drift velocity. So now the equation becomes current density is equal to N, where N is a carrier density, E is charge, mu is mobility of carrier, and E is electric field. So where we use the relation drift velocity is equal to mu times electric field. So conductivity, the definition of conductivity is current density per unit electric field is defined as conductivity. So conductivity is J upon E. So let us verify how it came. So for resistance, we know resistance is equal to V upon E. So potential upon current. And similarly, for potential, we have the relation electric field into distance is called potential. Potential is dv upon dr is equal to E. So you can say for a uniform condition, E into length means E into distance ed is equal to potential. So this one, and I is J into A. So J into A is current. So let us use this relation, R is equal to ed upon J into A. So it becomes, so let us transpose R into A by D. So we have E upon J, which is rho. So 1 upon rho, that is resistivity. 1 upon rho, we know, we say resistivity as a inverse of conductivity. So we can write conductivity is equal to J upon E. Now we have a relation sigma is equal to, so sigma is conductivity, sigma is equal to J upon electric field. That is Ne mu E upon E. So where J in above part we have written J. What is J? J is NEA into mu E. Let us refer to this equation. What is J? J is this one, NE into mu E. So this becomes NE mu E. So this is Ohm's law in electric field format. For holes and electron, we can write this. We have different values of N and mu. So total conductivity will be given by E is equal to Ne into mu E plus Np into mu P. So this is charge density, number density for for holes, and this is mobility for hole. So now let us refer N, the subscript N to be used for electron and P for hole. So the drift velocity for electron will be given by Vn is equal to mu n into electric field. Similarly, Vp is the drift velocity for hole is will be given by mu p into E. So Jn, now current density becomes J is equal to E into N into mu into E. So for uh, for electron it will be Jn mu n Jn E into N into mu n into E. Similarly, for holes, it will be E into P into mu P into E. Similarly, total total current density will be Jn for electron and Jp for holes. So total current density will be charge into electric field into number density into mobility of electrons and mobility of hole into density, number density of hole. So from the physics law, we know diffusion. Diffusion will be given by change in concentration. So the flux will be directly proportional to change in concentration of number density. So what is Fick's law? Fick's law states that when you have difference in concentration of charge carriers, Suppose here the concentration is more dense and there is less density or less number of carriers. So what will happen? Uh, to maintain equilibrium, some electrons will move this side, and similarly for holes. So, change in concentration with respect to some distance is called gradient. So, here the flow will be flow flux is something which is related to flow, and the flow will be directly proportional to change in concentration gradient of carrier density, that is dN by dx. So, it will be given by uh, flux Fn is equal to dn proportionality constant into dn upon dx. Similarly, for holes, it will given by Fp is equal to dp, that is constant, upon into dp upon dx. And current density in this scenario will be Jn is equal to E into dn by dx, and Jp is equal to E, that is charge of here. Concentration gradient is in opposite to the direction of the flow. So density is somewhere the density is maximum, the flow will be opposite from it. It is like this. When suppose here the concentration is maximum and somewhere else the concentration is lower. So what is that? So the concentration is decreasing in this direction, in this direction of arrow, the concentration is decreasing, but the carriers will move in the direction of decreasing. So the carriers will come out on this direction. So you can say that when it is the case of electron and the decrease where the concentration is decreasing, the current will be in its direction opposite to it. So that's why here is a plus, and for in the case of hole there is minus sign. So total current density due to the holes will be given by, so this is diffusion. So let us say Jn into D and Jp into D. So this is diffusion current, and now total current will be diffusion drift current plus diffusion current. So for electron it will be E into mu n into E plus E dn into dn upon dx. So for electron and for hole, at the equilibrium condition